Okay, good morning. My name is Yuri Platnikov. I'm a researcher at the Adaptive Automation Group. And today I'm going to talk about G133 generic project and task devoted to flexible inspection cell. So definitely for industrial application, for production application, there are many of different types of measurement and inspection tasks. We cannot cover all of them, but we want to just demonstrate how we can do some simplification, automation, and improvement reliability due to a reduction of the operator dependency. So what we done for this purpose is we put together several automatic stages. It's 4 stages. We built a graphic user interface that can control those stages together with data acquisition systems. We also use optical camera, which is physically aligned with rotary and X stage. So we can do visual assistant scan plan generation, and later we can retrieve those images and project a result of the measurements directly where they have been done. So that image on the left is showing the overall concept demonstration system. So it has 4 stages. Rotary stage and X, Y, and left-right stage is holding the part. In this case, the part is the cylinder, 4-inch in diameter, with several layers of bond coat and TBC coating for our testing purposes that we built. The sensors, we have 2 of them, a laser displacement with high resolution down to 1 micron, and as well as eddy current thickness, coating thickness gauge, which needs to be in direct contact with the surface in order to measure the coating thickness against the base material. So the first example of what can be done on this system is just 2-dimensional full part scan. In this case, we used the laser displacement, which was about 15 centimeters off the surface. And we rotated the part and did the vertical increments for the laser displacement sensor. So we were able to do like full 360 measurement coverage, surface coverage, and then render 3D image as shown on the right bottom. So definitely this X, Y, Z coordinates for each point shows the overall shape of the part, but you don't see on this image exact variation of the coating thickness because they are in like 1,000 times less than external dimension. If we project the coating thickness on like cylindrical template, you can see on the left-hand side, this is what we wanted to have. It's like per design. On the right-hand side, this is what we actually got. And the variations are in the range of about 30 to 50 microns, and those are mostly due to non-cylindrical shape of the pipe because it's a welded pipe, as well as some non-ideal positioning and low precision of our low-cost stages that we use to do this data acquisition. But overall, on the bottom, you can see the thickness profiles like coating versus vertical position. On the left-hand side is what we intended to have, and on the right-hand side, what we actually got for these displacement measurements. But to demonstrate the flexibility of the measurement, we want to show another kind of measurement. And in this case, it's eddy current sensor gauge that we can place to a particular point on the part and have more precise, more stable measurement against the base material that we have on the part. So and that's a typical kind of operation that you can see on the production plants where operator conduct several measurements on a TBC coating after plasma spray and write down the results. Here, definitely much easier to do this job by going over the image and clicking points where you want to do measurement. And that program would do the automatic scan plan generation, and later you can repeat it as many times as you want if you have many parts to assess. So the program will execute the actual scan, and then to review result, you will see the same images retrieved from the memory, and we have values of coating thickness superimposed over the particular point of measurement. I have a short video that will run and show all these results in action. But from a measurement standpoint, certainly we see that the eddy current test probe has very high gauge resolution. It's down to ±1 micron if we do replication of measurement over the same path. And the TBC coating on the chart, you see, it has much larger variation because you cannot do exact smooth and uniform surface with plasma spray process. So now I just want to emphasize that that demonstration is just the principle of what can be done, and certainly each particular case is different, and we can adjust our parameters, test gauges, the protocol to a particular application. So going to the demo, it just will give you the overall perspective of how it's done in real life. So the first is three-dimensional measurement with this laser Keynes laser displacement. So it can measure distance between sensor and the surface at the range of about 15 centimeters in the and measurement accuracy is down to 1 micron. So this is where how it goes. It's we are rotating the part and continuously acquiring the data. And after one turn is completed, the vertical increment will go and move this sensor up. So at the end of the day, we have, or end of the scan, we have this 3D rendering. And also we can extract some particular thicknesses. And you can see that there is a difference between what we wanted to have in ideal scenario and what we got. Another example is scan plan generation. As I explained earlier, it's an image, optical camera image, where you just go with your cursor and clicking on the point where you want to do measurement. So the scan plan is generated by coordinates. Those coordinates link to the images that we are also acquiring. So we can play back what we have done afterwards. So here you see the gauge, the thickness gauge in microns on the right bottom. So you see it's the variations in the range of 1 micron over different repetition, but we certainly measure in much larger. It's about like 20 to 30 increment from 1 to 2 to 3 passes over the part with a plasma spray coating. And certainly over the circumference, we see a much larger variation in thickness, and we know that it's due to actual process, not gauge, because gauges is really precise and really high reliably measurement device. So that result is like 5 replication of the same scan, very high precision down to 0.5 microns, and this is actual result that we got from TBC measurement. So again, system is showing the concept of multiple sensor combination and a way of automate and make non-destructive testing or metrology measurement more reliable and more reproducible.